In this video, we'll discuss about Henderson-Haselbalch equation and its application. The relationship between pH, pK and concentration of weak acid. So, the relationship between pH, pK value and concentration of weak acid and conjugated base is expressed by Henderson-Haselbalch equation. So, pH we know, pK value product by reactant. So, here that equation is used to find out buffer solution pH, acid buffer, weak acid and its salt. Acid buffer means weak acid and it is salt. pK value means here product by reactant. pH negative logarithm of hydrogen ion concentration. That pK strength of an acid on a logarithmic scale. pH is equal to pK log of base divided by acid. It can be used to determine which proportion of an acid is in the protonated or deprotonated state as a given pH. So, protonated or deprotonated state at a given pH. How that derivation of Henderson-Haselbalch equation. Dissociation of a weak acid yield a conjugate acid-base pair. So here Ha is the weak acid. This one is dissociated protons plus conjugated base. It is a reversible reaction. So weak acid dissociated to form protons and conjugated base. It is a reversible reaction. By definition, the dissociation can state K of that acid is this K. This one is the dissociation constant. H means proton. Then A minus conjugated base divided by weak acid. So, dissociation constant proton multiply conjugated base divided by weak acid. So, the above equation can be written as hydrogen ion concentration. Here, dissociation constant above here. HA means weak acid divided by conjugated base. By taking logarithm of both side and multiply by -1, we will get equation minus hydrogen ion concentration equal to minus log that dissociation constant the pK minus log of weak acid and conjugated base. So here minus log is pH minus K plus, this one is the pK value. Substituting pH for minus log and pK for minus log K. So pH equal to pK plus log this one conjugated base divided by weak acid. This one is the pH is equal to dissociated constant plus log of conjugated base divided by weak acid. So now applications of this equation can be used to calculate change the pH of a buffer on addition of known quality of acid and alkali. For example, When a strong base NaOH is added, acetic acid is converted in its conjugated base. NaOH plus that HA, weak acid, it will give conjugated base plus water plus Na. Changes in the ratio of base is acid occur, causing changes in pH of that medium as can seen from the equation. Another important application of this equation to find concentration of acid base by measuring pH. Another biochemistry clinical application assessing that acid base status, severity of acid base disorder, and predicting that limits of components of body buffer. So in this video we are discussing Henderson Haselbalch equation and other application. pH is equal to pK plus log of base divided by acid. Weak acid is dissociated to proton and conjugated base. It is a reversible reaction. Thanks for watching.